Hello everyone. We introduce to you our final year project Automatic Sewer Lines Blockage Removal and Waste Segregation System by Vasudev Reddy P, Uday V, Vikas B and G Pretika, guided by Professor Anupama and coordinated by Professor Ezil Arasin. Water scarcity and water management are major problems in India due to constant increase in population and urbanization. As per the latest assessment, out of 22,900 million liters of wastewater being produced, only 5,900 million liters are being treated. The remaining water is being let into rivers and other water bodies without being treated. This is because most of the wastewater does not reach the water treatment plants due to blockage in sewer lines. Hence, there exists flooding of wastewater on roads, hindrance to traffic, and health issues to general public. There exist numerous methods of blockage removal, but there are not efficient methods. The majorly practiced method is sending a sanitary worker into the drain to remove the blockage. This is a very harmful method. Another major problem that exists is that the majority of waste that is being accumulated is not segregated for proper disposal. To overcome these problems, we have developed a system which aims to minimize the manual intervention with respect to the blockage removal of sewer lines and pass more water to water treatment plants. The following are the objectives of the proposed system. Remove blockage and permit more water to water treatment plants, avoid flooding of wastewater on roads, increase the amount of wastewater being treated, segregate the waste into degradable, non-degradable and metal wastes, provide a cleaner, sanitary and healthier environment. The figure shown here shows the proposed module which contains 3 units: accumulation unit, segregation unit and communication unit. The accumulation unit collects the solid waste that are present in the flow of wastewater. Segregation unit segregates them into degradable, non-degradable and metal wastes. The communication unit informs the authorities about the filling up of the bins. Now the components used in the project are discussed. The main controller of the system is ARM7 TDMI LPC2148. It contains 64 pins, 32 bits, 51 KB on-chip flash memory and operates at a frequency of 12 MHz at each of the ports. The set of sensors that are used are water level sensor FC28D, capacitive sensor HR202, metal proximity sensor M12 and IR sensor. The water level sensor contains 2 electrodes and is a digital sensor. The capacitive sensor is used to measure the amount of moisture present. It is an analog sensor which inputs values to the ADC of the microcontroller. The metal proximity sensor senses the presence of metal object and produces an output of 12 volts. IR sensor contains a transmitter and receiver which transmit and receive infrared rays. When there is any change in this, it produces an output of 3 volts. A potentiometer is connected with the water level sensor to connect the input of the voltage to the microcontroller to be 3.3 volts. An optocoupler bypasses the 12 volts output from metal proximity sensor to 3.3 volts. There exist three 12-volt DC motors of 60 rotations per minute for swiping action, lifting action and rotating action. 6 12-volt relays are used for anti-clockwise and clockwise rotation of the motors. A 12-volt to 5-volt connector circuit is used to provide separate 12 volts and 5 volts power supply. A 16 cross 2 LCD displays a message at every action of the microcontroller. GSM SIM 300 module is used to send message to the authorities, and the GSM driver circuit is used to provide 4.3 volts as input to the GSM module. Friction gears are used for swiping and lifting action. A metal plate is used as a wiper blade, and 3 metal baskets are used to collect the segregated waste. A metal plate is used to collect the accumulated waste and lift it up to the segregation unit. The working of the automatic sewer line, blockage removal and waste segregation system will be demonstrated now. The LCD shows the display of drainage system. This module is assumed to be placed in the drainage system. We can see that there is a mesh that is being placed to filter the solid waste in the flow of water. It accumulates all the solid waste, and when there is a blockage detected, the water level rises. This rise in water level is indicated using the water level sensor. The water level sensor indicates it. The wiper blade is used to wipe out the accumulated solid waste. The LCD indicates the drainage is filled and waste is to be accumulated. Meanwhile, the accumulated waste is raised to a higher level and placed in that level to drain the excess water. The higher level is called a segregation unit. It consists of 2 sensors, humidity sensor and metal detector. Humidity sensor detects between degradable and non-degradable waste. Metal detector detects if the waste is metal or not. The humidity sensor detects dry waste and the message is being displayed on the LCD. After the LCD displays dry waste, then the waste collection bin disposes the waste into non-degradable waste bin. A message is then sent to the authorities about the non-degradable waste. There also exists IR sensor to indicate the filling up of the bin. When the bin is filled, a message is sent to the authority. The LCD displays that wet waste is detected. As soon as the wet waste is displayed in the LCD, the collection bin lowers down near the degradable waste bin and drops the waste into the bin, and then it goes down to a lower place as before. When metal waste is detected, the LCD displays metal detected. Soon after metal is detected, the bin lowers to an even lower place where metal waste bin is kept and places the waste into the metal waste bin and goes back to its original position. This system seems to be more efficient than the previously existing system, and the system can be made wireless for future work. Thank you.